Okay, so in this video, we're gonna look at a few more examples of measuring distance, mostly focusing on it if we just have a triangle. So I want to find the length of this missing side. We want to do these using the Pythagorean theorem. The main thing is just making sure you get C right. So in this case, A is my smallest side, B, and then C would be the side across from the right angle. So that would be X. And then we just do our Pythagorean theorem. So we would do A squared plus B squared equals C squared. So 8 squared equals C squared. That gives us 16 plus 64. Okay, so that gives us 80 equals C squared. Okay, and then we take the square root of both sides and we get 8.944. Okay, now some of them are going to ask you, it's called simplest radical form, which is simplifying this. So to do that is what you want to do is you want to find the largest perfect square that divides into this. Okay, so perfect squares are like 2 squared is 4 and 3 squared is 9. So 4 and 9 are perfect squares. They're the number that you can take a square root and get a whole number. 4 squared is 16. 5 squared is 25. 6 squared is 36. And you might have to keep going. 7 squared is 49. 8 squared is 64. 9 squared is 81, and 10 squared is 100. Okay, so these are my perfect squares. There are more if you kept going. And so if you have to get this in simple radical form, you want to find the largest perfect square that divides into this. So if I go kind of down the list, starting large, so 64 does not go into it. I mean, 81 and 100 don't because they're larger. 49 does not go into it. 36 does not divide evenly into 80. Neither does 25, but 16 does. If you do 80 divided by 16, you get 5. So like, for example, what I'm doing is if I do 80 divided by, let's say like that 25, that I get a decimal. So that doesn't divide evenly into it. So I want to find the one that doesn't give me a decimal, which is 16. So I'm going to make 80 16 times 4, because that's the same thing as 80. And then I can take, 16 times 5. And then I can take the square root of both of these separately. So I can take the square root of 16 and then the square root of 5. And we know the square root of 16, which is 4. I don't know the square root of 5, so I'm going to leave it there. And this is the simplest radical form. And the simplest radical form means that there's no perfect square that divides evenly into this number anymore. If there is one, then we can take it out. So this is the example of simplest radical form. So some of the homeworks will ask you for that. Okay, so again, triangles, we're going to find the missing side. Well, this one we have to be careful because now I know the C is 11 and I'm missing A or B. It doesn't really matter which one you call A and B for the legs, but I'm missing one of the legs. So when I do that for setting this up, I'm going to do A squared, so X squared plus B squared equals C squared. And my C now is a number, and then I'm going to have to solve this. So I square both of these, and then we need to get the X squared by itself by subtracting 49 from both sides. Okay, that gives me X squared is equal to 72. Then X, we take the square root of 72. Now as a decimal, that's like 8.485. In that simplest radical form, again, I'm dividing by those perfect squares. Oh, I forgot 25. Okay, and again, I get it by 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7. I forgot 7 squared as well. 49, 8 squared. Okay, so I want to find the largest one of these that divide into it. So 64 doesn't, 49 doesn't, but 36 does. 72 is the same as 36 times 2. And then I can take the square root of both of them. I know the square root of 36 is 6, so that's 6 the square root of 2. And one way to check is you could take, put this in your calculator, 6 the square root of 2. And then also do the square root of 72, and you should get the same answer because they should be equivalent. So if not, then you made a mistake when you simplified it. Okay, so for one more, find the value of x. So x is here. Now, they told me this angle is 45. We know this angle is 90. We can find this angle by doing 180 minus 90 minus 45, which is going to give us 45. And then because two angles are equal, we know it's isosceles, which means this side and this side are equal, the two sides that are across from the equal angles. And so this is 5. And now I can use my Pythagorean theorem to find x. So this would be A, this would be B, this would be C. So we do a squared plus b squared equals c squared. Okay, and then I'm going to simplify. Okay, so I get 50 equals x squared. So this is the square root of 50 equals x. Okay, again, if I'm going to simplify it, I think about one of those perfect squares that divide into it. The largest one is 25. This is 25 times 2. And so I can take the square root of 25 because I know that one. And that's 5 the square root of 2. And then again, if I take the square root of 50 or 5 the square root of 2 in my calculator, I should get the same answer. And I get 7.071. Okay, so this is the simplest radical form. This is the decimal. Okay, so those are all examples on how to do the Pythagorean theorem.